Hello children, so today's new topic we are going to understand the topic optics. So what is the meaning of optics? Optics is nothing but it's a branch of physics which deals with the properties of light and which tries to explain the various phenomena exhibited by the light. And under the heading of this optics we have the two subtopics. One is the ray optics, another one is the wave optics. In the ray optics, when we will read with the ray optics, when we will study with the ray optics, so whenever the wavelength of the light whatever we are using, and here b is nothing but the size of the obstacle and lambda is nothing but wavelength. Whenever the wavelength of the light that is used is very small compared to the size of the obstacle, then we will study everything under the heading of ray optics. And what is the meaning of this ray optics? In this ray optics, everything we will study based on the rectilinear propagation of light. The light has one of the property, rectilinear propagation of light. That means what? The light will always go in a straight line manner. So based on that property, we will study the various effects shown by the light, and that is nothing but ray optics. And this has another name, geometrical optics. And what is the meaning of wave optics? When we will study under this heading, whenever the wavelength of the light what we are using, if it is equal to almost equal to size of the obstacle, or if it is just more than the size of the obstacle, then we will use the wave optics. In this wave optics, everything we will study with the help of wave theory of light. So here wave theory of light, here is the rectilinear propagation of light. That is a major difference between ray optics and wave optics. Now here our interest is all about the ray optics. So today we will start with the ray optics, understanding of ray optics. First of all, let us know the very important and simple phenomena, that is reflection of light. Let us know about the reflection of light. What is the meaning of reflection of light? Reflection of light is nothing but the phenomena in which the light, when strikes the smooth surface, it tries to bounce back, so by making some angle with the normal. So here it is, let us suppose a smooth surface. I am assuming it is like a plane mirror. When the light strikes the mirror, then it will try to bounce back, such that with the normal, the incident light ray and reflected light ray makes an angles of I and R respectively, such that the angle of incidence and angle of reflection are always equal to each other. This is nothing but one of the law of reflection. And the incident light ray, reflected light ray and normal, all three lies always in one plane. Those two are nothing but what? Laws of reflection. And so let us try to extend this incident light ray direction. Then the angle between extended incident light ray direction and finally reflected light ray will be called as a angle of deviation. Delta is nothing but angle of deviation. And here we have one formula for it. What could be it is? So in this diagram you can observe this total angle is nothing but 180 degrees. This 180 degrees is comprising of three angles, delta, R and I. Therefore 180 degrees is nothing but what? Delta plus I plus R. So from the laws of reflection, R can be equal to I. Therefore what I can write? Delta plus 2I equals to 180 degrees. Therefore the angle of deviation is given by 180 degrees minus 2I or 180 degrees minus 2R. Both the formulas are same. This is the formula for angle of deviation. And let us understand some important result that can be obtained from the mirror. So first of all, let us fix the mirror. The mirror is not moving. The mirror is not moving. Now let us suppose the incident light ray is turned through angle theta. Then what will happen for reflected light ray? The reflected light ray will also turn through same angle theta but in the opposite direction. That you can understand from this diagram. Let us suppose this is a plane mirror, and here I have an incident light ray and this is the reflected light ray. And so let us suppose it is turned through some angle theta in clockwise direction. Then obviously to make the incident and reflected light ray angle same, the reflected light ray will also turn through the same angle but in the opposite direction. So if it turns in anti-clockwise, then it will turn back by clockwise direction. In that way, to make incident angle and reflected angle same, the light rays will converge. I mean, they will move towards each other. They will rotate. They will turn towards each other. So therefore, incident, by fixing the mirror, if the incident light ray is turned through angle theta, the reflected light ray will turn through the angle theta, same angle only, but in the opposite direction. And next result, what is it is? Here, I would like to fix the incident light ray the incident light ray is fixed. Then if I turn the mirror through some angle theta, then what will happen for reflected light ray? Reflected light ray will turn through double of that angle. That can be noticed from this small experiment. So let us suppose there is a one light ray which is striking the mirror straightly, I mean perpendicularly. Therefore what will happen? It will be turned back through the same direction. And here what is the incident angle? 0. Reflected angle is also 0. Now let us suppose it has turned through some angle theta. The mirror has turned through some angle theta. Then obviously the normal made by the mirror will also turn through the same angle. So now theta is the angle made by incident fixed light ray with the normal. Therefore obviously I will have a reflected light ray which will have the same angle that will be made by the normal. Therefore, so this is an incident light ray, this is the new reflected light ray, and this is a previous reflected light ray. Let me represent with a double arrow, and it is nothing but triple arrow I would like to represent. So the single arrow line is nothing but incident light ray, the double arrow is nothing but first reflected light ray, triple arrow is nothing but the finally reflected light ray when the mirror is turned through some angle theta. Now what is the angle between these two? 2 theta. Theta plus theta, 2 theta. That's what here we have written. So therefore whenever the incident light ray got fixed and if the mirror is turned through some angle theta, then the reflected light ray will turn through double of that angle of rotation or angle of twist. So these are the some important result that can be obtained from the reflection process. And let me give you some more important result. Okay, so here we have like this. Let us suppose here is a person who is standing in front of mirror. Then what is the maximum height of a mirror? What is the maximum height of a mirror required to see his full height? So let us suppose here I have mirror, some plain mirror, and one person is standing. So let us suppose this is the eye position. So this is the forehead, this is the eye position, this is the person who is standing in front of a mirror. Now he could able to see his bottom. So let us suppose the light ray from his bottom, from his feet is striking here and reaching to his eyes in this way. And in the same way his top also striking and reflecting here. So I would like to draw it again. Let me write. Just 1 second, I will draw it again. By seeing the diagram itself, everything you could able to understand. So here I have a mirror, and what's happening? So light is incidenting here, and it is reflecting back here. I'm sorry. So this is nothing but incident light ray, and this is the reflected light ray. This is the incident light ray from the feet and reflected light ray which is reaching to the eyes. And now here this is nothing but the maximum height. So let us suppose h1 is nothing but height of his feet. The level of his feet and eyes are separated by the distance of h1, and his head, total head height is h2. Now what you can observe, so this is nothing but that you can understand like this. Yes, now it will give you a clear picture. Compared to that, here it will be easy to understand. See this one. So let us suppose it is nothing but h1 is the height or distance between the feet of the person and the eye location, and this is nothing but a remaining distance from his eyes to up head. And now this could be regarded as, what could be this distance? h2 by 2. Now what could be this distance? h1 by 2. This total distance is h1 by 2. So the minimum height of a plane mirror required to see the full image is nothing but h2 by 2 plus h1 by 2. So totally what I can write, h1 plus h2 by 2. So if capital H is the total height of a person, what I could say, h by 2, which is nothing but the height of a mirror which is required to see the complete image of a person. This is the one of the important result. And there is one more result which you need to remember, that is nothing but, so let us suppose there is a one room with a tall wall. So here I have the one person who is standing at somewhere in between the walls, and there is a one mirror here. So if he want to see the full image of the wall which is behind him, so he is seeing in this way, and he want to see the full image of the wall in this mirror, then what could be the maximum height of a mirror? The maximum height of a mirror which is required to see the full image of a wall is nothing but just h by 3. If h is the height of a wall, then the maximum height of a mirror which is used to see the full image of a vertical wall is nothing but h by 3. And this no need to prove here, that can be also drawn like this only, like this it will be. From here, by making small geometrical small things, so if we do this, then we will get here the h by 3. A small modifications if you perform, then you will get h by 3. It's very simple only. It's all about the properties of triangles and the geometrical laws. That's all. Well, so this is what the two important and useful results. And with this, the reflection on a plane mirror, it is over, and we will understand about the reflection taking place on curved mirrors. So we have two kinds of curved mirrors. What are spherical mirrors are curved mirrors? What are they? One is the convex, another one is a concave. And let us know about what is the mirror formula. What is the mirror formula? The mirror formula could be written like this: 1 by f equals to 1 by v plus 1 by u, where u is nothing but object distance that is measured from the pole of the mirror to the object location. And what is the v? V is nothing but image distance. The same way, if we will measure the image distance from the pole of the mirror to the location of an image. And here finally we have to define one more thing, that is a magnification. What is the meaning of magnification? The height of an image by height of an object, so which will be also